Welcome, grade 8 students. How are you? Okay, are you good? Okay, so please go to www.cathomeschool.com. Then click for the curriculum and please enter the password. Alright. Then after that, you may click the subject math, because that will be, we will continue our lesson last time. So let's go for square root and cube roots. So, are you ready? Okay, so then we'll start. Can you see this? Okay. So, square root and cube root. To find the square root of a number, you want to find some number that when multiplied by itself gives you the original number. In other words, to find the square root of 25, you want to find the number that when multiplied by itself give you 25. The square root of 25 then is 5. The symbol of square root is this one. Okay, this is the symbol of square root. Following is the list of the first 11 perfect or whole number square roots. So, examples of square roots. So, the square root of 0, 0, the square root of 1, 1, 4, 2, 9, 3, 16, 4, 25, 5, 36, 6, 49, 7, 64, 8, square root of 81, 9, square root of 110. So, if no sign is placed in front of the square root, then the positive answer is required. Only if a negative sign is in front of the square root is the negative answer required. This notation is used in many texts and it's adhered to in this book. Therefore, the square root of 9 is 3, and the square root of negative 9 is negative 3. Next, the cube root. So to find the cube root of a number, you want to find some number that when multiplied by itself twice gives you the original number. In other words, to find the cube root of 8, you want to find the number that when multiplied by itself twice gives you 8. So the cube root of 8 then is 2, because 2 times 2 times 2 times 2 is 8. Notice that the symbol of cube root is the radical sign with the small 3, or it's called index, above and to the left. So here is it, the sign. Other roots are defined similar and identified by the index given. So here is some examples. Okay. Okay, next. Approximating square roots. To find the square roots of a number that is not perfect square, it will be necessary to find an approximate answer by using the procedure given in sample. So here are some examples. So the approximate of square root of 42. Since 6 is to 2 equal to 36 and 7 is to 2 is equal to 49, then the square root of 42 is between 36 and 49. So, therefore, the square root of 42 is value between 6 and 7, since 42 is about halfway between 36 and 49. You can expect that square root of 42 will be close to halfway between 6 and 7, or about 6.5. To check this estimation, 6.5 times 6.5 equals to 42.25, or about 42. So, square roots of non-perfect square can be approximated, looked up in tables, or found by using a calculator. You want to keep these two in mind. So examples, here are some examples. So simplifying square root. Sometimes you will have to simplify square root or write them in simplest form. For example, in fraction, 2 over 4 can be reduced to 1/2. In square roots, 32 can be simplified to 4 square root of 2. There are two main methods to simplify a square root. So first method, factor the number under the square root into 2 factor, one of which is the largest possible perfect square. In method 2, completely factor the number under the square root into prime factors and then simplify by bringing out any factors that came in pairs. So, for example, here are some examples. Okay. So we also have example here in the largest perfect square is easy to see, and method 1 probably is the faster method. So examples of method 1. So we have to simplify square root of 2016. So method 1 is square root of 2016 is equal to square root of 144 times 14. So you have to times the square root of 144 and the square root of 14. So you'll give the answer of 12 square root of 14. So it's easy to do the method 1 instead of method 2 for large numbers. So it is not obvious that the large perfect square is 144, so method 2 is probably the faster method. Many square roots can be simplified because they are already in the simplest form. Okay, don't worry class, because I have this video here. If you don't understand, let's all watch this. This video will surely help you to understand more about okay.
A root, usually the directions will say just simplify. This 2 is referred to as, when looking for a square root, usually the directions will say just simplify. This 2 is referred to as the index. This symbol is referred to as the radical sign, and the number underneath the radical sign is called the argument or the radicand. The idea of a square root is you think of what number times itself will give you 49. So you just run through the numbers in your mind. And in this case, 7 times 7 would give you 49. So the square root of 49 is 7. By the way, this index of 2 is not required. If you simply have a radical symbol with no index indicated, then it's understood to mean the square root. So again, the square root of 49 is 7. The square root of 100, if you think of 10 times 10, that would give you 100. So the square root of 100 is simply 10. Notice when I write the 10, there's no more radical sign, or radical symbol over it. You write the number without the radical symbol once you've taken the square root. The radical symbol is also considered a grouping symbol. Okay, so this symbol groups together everything that's underneath it. So this says, if you can remember order of operations, you address grouping symbols first. So I can add the 17 and the 8. That would give me 25. But the radical sign has not been used yet, so it comes down. Okay, slide this up. And the square root of 25 is 5. So that's your answer. We'll do a few more. The square root of 64. 8 times 8 is 64. So the square root of 64 is 8. As the numbers get larger, you might have to do a little bit more thinking. Remember, the square root of 100 is 10. So the square root of 144 is going to be more than 10. You might try 11. That gives you 121. That's not what we seek. Try 12 times 12. There. So the square root of 144 is 12. Looking at our next case, remember the radical sign is a grouping symbol. So first we'll handle 95 subtract 14, and usually I'll do my scratch work off to the side rather than underneath, okay, because I want to put the result underneath. So off to the side. So 95 subtract 14 gives us 81. I put that result here. And then I bring down the radical sign, or excuse me, the radical symbol, because I have not used that yet. Alright? Now I take the square root. The square root of 81 is 9, because 9 times 9 gives us 81. So the square root of 81 is 9. Again, we have a grouping symbol. So first we'll combine those two numbers. This you can probably just do in your head. 100 plus 21 is 121. But again, I have not taken the square root. All I did was combine what's inside. So you bring down the radical sign, and now you have to find the square root of 121. If you've done many of these, you might have some scratch work on the side that reveals the answer. We happen to know it's 11. Okay, now the index is 3. Again, the index is 3, and that says we're looking for the cube root of 8. The cube root of a number is the number times itself 3 times that gives you 8. So for instance, we'll start with something small. 2 times 2 times 2. 2 times 2 would be 4. Takes care of them. Bring that one down. 4 times 2 is 8. Takes care of them. So the cube root of 8 is 2. Another way to express this would be 2 to the third power is equal to 8. So notice taking the roots and raising to powers are opposite operations. The cube root of 64 we'll try 3 times 3 times 3. 3 times 3 is 9. Bring that down. 3 times 9 is 27. That's not what we seek. We'll try 4 times 4 times 4. So these first two gives us 16. Bring down that 4. 16 times 4 is 64. And that's what we're looking for. So the cube root of 64 is 4. I could have circled my answer up here. You can see cubes get large quickly. So I'm not going to get too carried away with this, but we'll look at the cube root of 125. Well, we tried 3, we've tried 4. Let's try 5. Five times itself 3 times. This would be 25. Takes care of them. Bring this guy down. Sorry, that's a 5. And 25 times 5 is 125. Takes care of them. So the cube root of 125 is 5. Keep in mind that the radical symbol is a grouping symbol. So first we'll add the 20 and the 7. That will give us 27. But again, I have not taken the cube root of this number. I've only combined what's inside the radical symbol. So I still have to find the cube root of 27. And a little bit earlier in our work, we found that 3 times 3 times 3 gives us 27. So the cube root of 27 is 3. I'd like to go over a few more cases that might look strange. The square root of 1. Remember, there's no index here, so it's understood to be an index of 2, which means the square root. The square root of 1 is simply 1. You do have to be careful when negative signs show up. The negative square root of 9 can be found because the square root of 9 is 3, takes care of that. Now this negative sign just comes straight down. So this is our answer. However, the square root of negative 9 has no solution in the real numbers. And for number, I'll just put that symbol. Because if you think about it, how can you have a number times itself that gives you a negative value? So whenever you can't, at least not in the real numbers. We have complex numbers where there is a solution, but you're not called on to deal with that just yet. So you have to realize if there's a negative underneath the radical symbol, there's no solution. Usually this answer is sufficient. So again, the negative square root of 1, square root of 1 is 1, and this negative sign just comes down. So this one you can answer. But in this case, there's no solution. Alright, technically it's no solution in the real numbers, but people are usually happy with just an answer like this. Now, unlike square roots, where you have to be very careful about negative signs, with cube roots, they don't cause a problem. So we've already figured out the cube root of 8 is 2. And in this case, the negative would again just drop down. Over here, if it was a square root, we'd have a problem. But because it's a cube root, we'll -2 times -2 times -2. These would give you a positive 4. That's gone, that's gone. Bring this guy down. Times -2. This gives you a -8. So you can see that's what we're looking for. So the cube root of -8 is -2. Negative cube root of 1. The cube root of 1 is 1, and the negative symbol just comes down. The cube root of -1 is simply -1.
Okay, so here's another video so that wait, so okay. Okay. This is all about cube roots. So let's all watch this.
We already know a little bit about square roots. For example, if I were to tell you that 7 squared is equal to 49, that's equal.
Oh, what happened?
We already know a little bit about square roots. For example, if I were to tell you that 7 squared is equal to 49, that's equivalent to saying that 7 is equal to the square root of 49. The square root essentially unwinds taking the square of something. In fact, we could write it like this. We could write the square root of 49. So this is whatever number times itself is equal to 49. If I multiply that number times itself, if I square it, well, I'm going to get 49. And that's going to be true for any number, not just 49. If I write the square root of x, and if I were to square it, that's going to be equal to x. And that's going to be true for any x for which we can evaluate the square root, evaluate the principal root. Now, typically, and as you advance in math, you're going to see that this will change. But typically, you say, okay, if I'm going to take the square root of something, x has to be non-negative. X has to be non-negative. non-negative. This is going to change once we start thinking about imaginary and complex numbers, but typically for the principal square root, we assume that whatever's under the radical, whatever's under here, is going to be non-negative. Because it's hard to square a number, at least the numbers that we know about, it's hard to square them and get a negative number. So for this thing to be defined, for it to make sense, it's typical to say that, okay, we need to put a non-negative number in here. But anyway, the focus of this video is not on the square root, it's really just to review things so we can start thinking about the cube root. And as you can imagine, where does the whole notion of taking a square of something or a square root come from? Well, it comes from the notion of finding the area of a square. If I have a square like this, and if this side is 7, well, if it's a square, all the sides are going to be 7. And if I wanted to find the area of this, it would be 7 times 7, or 7 squared. That would be the area of this. Now, or if I were to say, well, if I have a square, and that doesn't look like a perfect square, but you get the idea, all the sides are the same length. If I have a square with area x, if the area here is x, what are the lengths of the sides going to be? Well, it's going to be square root of x. All of the sides are going to be square root of x. So it's going to be square root of x by square root of x, and this side's going to be square root of x as well, and that's going to be square root of x as well. So that's where the term square root comes from, where the square comes from. Now, what do you think cube root? Well, same idea. If I have a cube, let me do my best attempt at drawing a cube really fast. If I have a cube, and a cube, all of its dimensions have the same length, so this is a 2 by 2 by 2 cube, what's the volume over here? Well, the volume is going to be 2 times 2 times 2, which is 2 to the third power, or 2 cubed. This is 2 cubed. That's why they use the word cubed, because this would be the volume of a cube where each of its sides have length 2. And this, of course, is going to be equal to 8. But what if we went the other way around? What if we started with the cube, or what if we started with its volume? What if we started with the cube's volume, and let's say the volume here is 8 cubic units, so volume is equal to 8. And we wanted to find the lengths of the sides. So we wanted to figure out what x is, because that's x, and that's x. It's a cube, so all its dimensions have the same length. Well, there's two ways that we could express this. We could say that x times x times x, or x to the third power, is equal to 8. Or we could use the cube root symbol, which is a radical with a little 3 in the right place. Or we could write that x is equal to, it's going to look very similar to the square root. This would be the square root of 8. But to make it clear that we're talking about the cube root of 8, we would write a little 3 over there. In theory, for square root, you could put a little 2 over here, but that'd be redundant. If there's no number here, people just assume that it's the square root. But if you're figuring out the cube root, or sometimes people say the third root, well, then you have to say, well, you have to put this little 3 right over here and this little notch in the radical symbol right over here. And so this is saying x is going to be some number that if I cube it, I get 8. So with that out of the way, let's do some examples. Let's say that I want to calculate the cube root of 27. What's that going to be? Well, if I say that this is going to be equal to x, this is equivalent to saying that x to the third, or that 27 is equal to x to the third power. So what is x going to be? Well, x times x times x is equal to 27. Well, the number I can think of is 3. So we would say that x, let me scroll down a little bit, x is equal to 3. Now let me ask you a question. Can we write something like, can we pick a new color, the cube root of, let me write, negative 64. I already talked about that if we're talking the square root, it's fairly typical that, hey, you put a negative number in there, at least until we learn about imaginary numbers, we don't know what to do with it. But can we do something with this? Well, if I cube something, can I get a negative number? Sure. If I say this is equal to x, this is the same thing as saying that negative 64 is equal to x to the third power. Well, what could x be? Well, what happens if you take negative 4 times negative 4 times negative 4? Negative 4 times negative 4 is positive 16, but then times negative 4 is negative 64, is equal to negative 64. So, what could x be here? Well, x could be equal to negative 4. X could be equal to negative 4. So, based on the math that we know so far, you actually can take the cube root of a negative number. And just so you know, you don't have to stop there. You could take a fourth root. In this case, you would have a 4 here, a fifth root, a sixth root, a seventh root of numbers. And we'll talk about that later in your mathematical career. But most of what you're going to see is actually going to be square root, and every now and then you're going to see a cube root. Now, you might be saying, well, hey, look, you just knew that 3 to the third power is 27. You took the cube root, you get x. Is there any simple way to do this? And, if I give you an arbitrary number, if I were to just say, I don't know, if I were to say cube root of 125. And the simple answer is, the easiest way to actually figure this out is actually just to do a factorization, in particular a prime factorization of this thing right over here, and then you would figure it out. So you would say, okay, well, 125 is 5 times 25, which is 5 times 5. All right, so this is the same thing as the cube root of 5 to the third power, which of course is going to be equal to 5. If you have a much larger number here, yes, there's no very simple way to compute what a cube root or a fourth root or a fifth root might be, and even square root can get quite difficult. There's no very simple way to just calculate it the way that you might multiply things or divide it.
Okay, so that ends our lesson for today. Please read and practice more and more practice so that you'll understand cube roots and square root. Thank you.